Yeah, drop, hey, huh.
We start by downloading the zip file, and we have it here. We unzip it with hack the box password, and we go into the challenge folder and we run it, and we see we have diagnostic center, log console. Let's try log console. Nmap scan performed, buffer overflow triggered, try to execute 𝗪𝗪𝗟𝗟𝗪, segmentation fault. Okay, so let's see, let's run one vulnerability scan. Okay, we see canary is on, NX on, no pi. There's a potential buffer overflow, but canary is on. Do you want to test that? Yes, I want to test that. And we insert a couple of A's, and let's see, boom, bus error. Okay, that was unusual. Let's try that again. 1 1. Yes, and a lot of A's. Blah 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 blah. Yeah, segmentation fault. That means there is indeed a buffer overflow here, and canary seems to be off actually. So let's check. It's a 64-bit binary and it's statically linked. Okay, this is why the canary is a false positive here. The actual binary does not have a canary, but because it's statically linked, it seems like it has. So if we proceed with that, we cannot execute techniques like 𝗪𝗔𝗪𝗟𝗪𝗪 and stuff like that because it's statically linked. So we're gonna rely on some syscalls. If we go here, this site, we see that in order to trigger some system calls like read, write, open, close, and stuff, we need to have some registers in place. So for example, in order to call read, you need rax to contain the 0 value, RDI an unsigned int file descriptor, RSI car pointer buff, and RDX size D count. So in our case, we're gonna use execv, which is similar to system, and we see that in order to call sysexecv, we need rax to contain 59, RDI to contain const car file name, RSI this one, and RDX this one. So execv actually needs the first argument, this one, to be the address of 𝗪𝗪𝗟𝗟𝗪, and the other two should just be null. So how we're gonna trigger them? First of all, let's try and see if we have these gadgets allowed here. So rope dash grep and pop RDI. Nice, we see we have a cool gadget here, pop RDI. It's not just a pop RDI red, but a pop RDI pop RBP. But this register here, we do not care about it. We will just fill it with junk and we're okay. So yeah, we have our first gadget. Let's try with RSI. Cool, another similar gadget here. Let's go with RDX. Okay, RDX seems a bit tricky. It doesn't have a simple gadget, but we have this we can abuse. So it's actually pop RDX, 𝗪𝗟𝗟𝗟𝗪, which we do not care right now, RBX, R12, R13, and RBP. This will just be filled with junk. It does not crash our program or anything, it doesn't affect us. And after that we need rax. Nice, pretty simple gadget here. And last but not least, we want the actual syscall. Boom, nice and clean. Okay, so let's try and craft our exploit right now. Vim solver.py. So first of all, we're gonna include our pawn tools. Then we're gonna open a process on our binary, which is Power Greed. and then diagnostic center here, r.sendLine_after, and it was like this one, and we send one, and after that we have val_scan, which is the same here, and then we have wanna test both, r.sendLine_after, I think it was this one, and yes, we want, and then trigger both, r.sendLine_after, and it was another this here, and we're gonna send our payload, which we haven't crafted yet. Before that, we need, first of all, our actually goal is to call something like this, exec_ve being sh, and then null, and not here, let's put it here. This one should have rax contain 0, RDI address of bin sh, and RSI should be null, RDX should be null, and then call syscall. Okay, rax RDI, RSI, RDX, that seems good. So we actually want to call this, but before that we need to find the overflow offset in order to override the return address, and we're gonna do this like this. We open GDB, we create a cyclic pattern here, we run the binary 1 1 yes, and then we insert the cyclic pattern, and we see on the top of the stack we take the first 8 bytes and we do cyclic -o here, and we see it's at 56 bytes. So let's, oh my god, let's proceed here. Craft rope chain. So first of all, the payload should start with a stamp 56 to avoid warning errors. We're gonna add some bytes here. Okay, after that we need, let's say, first craft RDI. So we need to find the pop RDI gadget, pop RDI, and we had like pop RBP and ret. So rope --grep and pop RDI. So this one is the correct gadget. So we go here and we send this. So this one is the pop RDI gadget and pop RBP gadget. That means it should be pop RDI, this one, and RBP should be null because we don't care. So we have this here. After that we're gonna have the pop RSI, pop RSI, pop RBP ret gadget, which is gonna be the same, P6404 RBP. And here we find this gadget, boom, and here. After that we should have our pop_rdx gadget, but this one was a bit what? Oh my god, I failed. Let's rerun this here. So we have pop_rdi, pop_rbp red, and p64. Here should be the address of bin_sh, which we're gonna find with, I think, find 0x43 and 0x49. These are segments of the binary, and we want the string bin_sh, and boom, we have it. So we're gonna take this here and have it in RDI, address of bin_sh into RDI, and then we want p64 0 into RBP. So we have successfully filled the first gadget. Then we want the pop_rsi, pop_rbp red. So let's have it cleaner here, and we need to fill RSI and RBP. So payload, we want both of these values to be 0, so we just do this, RSI and RBP null, and then we want p64, our pop_rdx gadget, pop_rdx, and this one was the tricky. We have it like, we have this huge gadget here, so it's like this, and the address is blah 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 right here. So we have this, and we start to fill all the registers. All of these values should be null, so we have 1, 2, 3, 4, and 5 registers that should be null. So right here we go null dash 5 times, fill RDX, RBX, R12, R13, and RBP with null. And last but not least, we want, oh no, it's not last, right now we want racks. So we go here again and search for the racks. Finally a nice gadget. So we go here, pop racks red, and this one should be 0. Nope, this one should not be 0, this one should be 59. EX contains 59 59 to trigger the syscall. And now we want the actual syscall, which is wait, this isn't correct. Let's rerun the binary. HTB Power Greed, and Here we have the syscall. Syscall. And now we need to trigger both, so we send the payload after that, and if everything went smoothly we should get a cell. And boom, we have cell locally. Nice. So let's try this remotely to see if it works. We go here, we start an instance. In the meantime, we need to change this to remote IP and port. So we're gonna have this. Like that. And let's see. Tries to open a remote connection and ID ls. We see that we can get the flag from here. So this was a challenge. Thank you guys for watching and see you in the next video.